Okay, so I was asked to give a talk here, and I wasn't quite sure what to talk about, but I realised just after I was asked that I've been in my particular job for 10 years, which meant that we'd just been using Moab for 10 years in our particular environment. And we were fairly early adopters of Moab, so I thought I'd just talk about some of the things we've been through. And WestGrid is one of the 4 regional consortias in Canada, in Canada. So we were initially formed in 2003 with machines going in 2003, with partners from British Columbia joining an existing project that was running in Alberta called Macy. So we expanded with partners in Saskatchewan and Manitoba in 2006. And so we currently have over 40,000 cores scheduled by Moab and over 10 petabytes of disk in production. So if you know where WestGrid is, you see you are there and WestGrid is here. So it's a little bit of a landmass, but there isn't that much in that bit of landmass. And so we have a number of sites that are actually participating as major providers. We have some sites which are just involved in terms of collaboration, and we have other sites that are involved with providing major resources. And so we have sites in British Columbia which are providing computing resources, in Alberta providing computing resources, in Saskatchewan providing a storage resource, and in Manitoba providing another computing resource. So in terms of our usage, our users, we're mainly big science. So computational use, we're very much dominated by chemistry and biochemistry, with physics as well, going down and down to right down to other, which includes medicine at 1%. So our actual funders are pushing us to be more involved in some of the humanities and medicine than we are now. If we actually looked at the storage, we find that physics just absolutely dominated the storage. So it's about 3/4 of the storage. So we also have a core network. We have our own network, which is built over links provided by the regional optical network providers and by Canary, the national optical network provider, that links to all our sites. And we also have links into the core backbone of the research network coming off these various sites. But we have our own network that's under our control with our own QoS, and most of it's running at 10 gigabits per second. So we are WestGrid. We were big on grid to start with. That particular time when we started, grid was a thing to be involved with. We were right from the start. We had a common grid stack, and we did choose Globus. And we still run Globus now right up to GT5. We still use single sign-on using X509 certificate-based authentication, and we support additional tools for people wanting to use grid, such as meta schedulers and certificate repositories. So we also support lots of other grid stacks. So we have access nodes particularly for other grid stacks such as the LCG. We currently run two LCG sites. We have had it at 3 sites in the past, and we also support Nimbus and Globus on another site. We also have Snow Plus, which I didn't put here, but all of our grid resources submit into our resource management site, which are then all controlled by Moab. So here are the major projects that are using these grid tools right now. Most of our users use Grid FTP in one way or another as a data transport tool. It's just much more effective than using SCP in a wide area environment. And we have more recently moved to supporting Globus Online as the primary tool because of its ability to connect to people's desktops. So over the years, in this 10 years, we've had two distributed file systems that we've run. The original one was an SGI CXFS system that ran over a distributed block system, which was really incredibly advanced at the time. Nothing else no longer exists, so much for that one. And we also ran GPFS for a time, but it was before they had their full caching model. At the moment, we're not running any shared file systems, so we're having to use other data management systems to move files around. And we also really tried to tailor different sites to different needs. We might go to a shared file system again, but if we can just tailor different sites to solving particular problems, there's less need for people to move around regularly. So in terms of scheduling, we were users of LSF and PBS, OpenPBS and Maui. At some sites on PBS Pro in the Mason project, and then moved on to Moab in 2003. So initially we were using Moab and scalable PBS was taught and exist back in those days. We did use Slurm on one system. I was checking some old emails between me and Dave Jackson, and we stopped using that because it just didn't work at the time. But obviously things have moved on now. But now we're completely Moab taught at the moment. And these are some of the systems that, right on the screen, some of the systems that have had to run Moab over the years. And, so, there's sort of some history here that you can't even remember most of these machines. But the Alpha Server ST45 was a very impressive system. At the time we bought it, it was an ST45 was the fastest machine in the world. And old Origin 2256 processors, so it was a huge shared memory system for the time. Anyway, we've run this on a lot of different systems, had to go through teething problems multiple times, and certainly have experience of working through those issues. So, use of Moab, we mainly use it for job scheduling, obviously, because that's the main thing it's for. And as I said, we have different policies of each site to try and tailor it to the needs. So by having different software at different sites, we also have different policies at different sites, and so those sites become tailored to specific needs of a particular group. We also use Moab to access licenses, to manage access to GPUs, for processing units. We also manage virtual machines on two systems, that's the Nimbus systems. And we also use it to manage system rebuilds and system reconfigurations. So we submit system jobs into the system, which when they get scheduled on a node can actually reconfigure and bring in new software. So for resource allocation, approximately 80% of each of the systems is allocated through the Canadian Resource Allocation Committee. And the main mechanism we use for our allocation on machines is fair share. We do this around accounting groups. So the accounting group is usually a professor and some group of students. And we've got a small weight in terms of fair share around users, just so there's a bit of fairness in the groups. But it's really all around those groups based on faculty members and their students. So we base our allocation around percentage of processor seconds available, and we track the fair share over 12 days. And initially, what we did with our fair share is we have our groups defined, but we use a fair share weight to actually weight a particular group to force that group up to a particular target. We now use fair share trees to achieve the same thing. And our fair share trees are generated out of LDAP, so we actually put all our information about allocations into LDAP. That information gets pulled out and pushed into Moab. And something I realised when I was looking through emails for this is that we actually originally asked for FS weight and for fair share trees to be implemented. So I don't know if other people weren't doing it like this before we got to it, but if you've used any of those things, they're things that we actually specifically asked and put into Moab. in terms of the scheduling, we really don't do anything that complicated now, because over the years we've tried lots of complicated policies, but if you just use max processor second limits on jobs, very large jobs using very large amount of resources are limited to a shorter wall time, and jobs that use less resources can use more wall time. So it's just a really flexible way of defining how much somebody can use. We do have some hard limits, so that when you at some point in the future, within 2 weeks, we can actually take the whole system down for maintenance when we decide to. But most of it's all decided by this maximum processor seconds limit. So we do have some small limits on the number of jobs and processor equivalents, so that's core and memory that somebody can use, but we don't have to be too worried about those limits, because the amount of use of max processor seconds gives us such a good control over how much any single job can claim the resource in any time period. We also have max iJob set, which says how many jobs are considered for scheduling from particular groups, and this just stops if one user comes in with a lot of jobs at one time. In one scheduling cycle, they can't take over the whole system. So it allows particular groups of jobs to be slowly fed into the system. Again, stops one group taking over a system, particularly after a system restart. And we have some of those particular limits over in particular groups. So if you're debugging or preemptible, if your job fits into a quality of service class of that sort, they may override some of those limits to allow those jobs to take more resources. So reservations are something that's just a really beautiful feature in Moab, and so we make reservations for system tasks. If you want to do some maintenance on the system, you put in a reservation, and then you can go in when the job's finished and do work on that part of the system to provide dedicated access to a particular group, or to restrict access to jobs with particular requirements. You may make an allocate, you may define a reservation just for large parallel jobs, or jobs using a particular type of software at a particular time, or for people with a particular need at that particular time. It's something that we're planning to do. I mentioned the talk I gave in 2007, and I announced here that we were going to do it, and now I've changed it to we are planning to do it. We'd really like to use user-driven reservations more, so for users that have a workflow where they want to run a job, look at results, run a job, look at results. We just never quite got around to really getting that into production, so we need to think more about that. And we actually had some features put into Moab to help us with accounting around that, to stop people using resources. So we really need to get on and actually use that stuff at some point. So another thing that we did a long time ago, right, really early on, is having this idea of a rolling reservation, where you push out time as to what a particular set of nodes can do. And so we did it initially just by having a little scripting language of our own, that every 10 minutes we change the set of reservations on the machine to push the reservations further out into the future. In the last few years, this has all been supported internally to Moab. And so one of the things we'll do is we'll have a floating reservation to keep some set of nodes, to try and keep some set of nodes available for particular types of tasks. Usually those are tasks that use whole nodes, tasks that need particular resources. So always within the future, there's either going to be some number of jobs that are using those resources, or there will be some number of nodes that will be available within a fixed amount of time. So that's a really useful feature to make sure that you don't starve particular types of jobs. Within those reservations, we also allow short and preemptible jobs to run, even if they don't fit the requirements of the reservation, just because there's not much harm in them running. So looking at tracking usage is really important, and we initially we wrote all our own tools to do this. when we did this, Moab didn't really have good graphical tools. They very quickly got good graphical tools, but by then we already had our own. Since then, we started using Central Compute Canada resources, so again, ones written by us. The reason for using those ones now is because there are different schedulers in Canada, so there's different formats coming in logging, and it's useful to just have one standard format for looking at all of this information for Canada. But developing and maintaining these tools is a lot of work. So I mean, if we could just use a commercial tool, we'd really like to do that. We happen not to do it. So over the years, we've spent a lot of time tuning Moab parameters to get good throughputs, and this is just a process that continues. And so user requirements change, software changes, so for various different times we find that the balance on the system changes, and we just need to make some adjustments to the configuration to get the best throughput. And so one of the parameters that we find very important is adjusting the backfill and reservation depth for different types of jobs to allow backfill to take place, but still have enough jobs to keep their reservations so they will start within a reasonable time. And so within Moab, everything is a reservation. So before a job starts, it makes its own reservation and then it starts. So we also had to use nested partitions on locality sensitive systems. So this goes right back to our ST35, which Quadrix Internet had a connectivity that meant that certain nodes were less suitable to have adjacent to others in the partitioning, but it's really been a huge issue with our SGI ultraviolet system. These big shared memory systems are incredibly complicated, right? You think clusters are complicated, but these big shared memory systems have so many restrictions on where you place memory and processors to get good performance. You have to have a very sophisticated setup, and I don't know. As these sort of technologies become more commodity, it's probably just going to be trouble for everyone, rather than just the people with huge, expensive SGIs. So Federated Moab, we've used Federation of Moab in several ways over the years. In one way was just as a monitoring mode and for collecting statistics. And that worked. We just didn't have quite enough motivation at the time to keep it going. We might do it again at some point, but yeah, it's just a case of how much effort you want to put into replacing existing tools when we have so much other infrastructure in place. We also tried to use it for balancing fair share information between sites. Don't stop that because it turned out not to be incredibly important to us at the time. We have particular allocations on particular machines, and for spare cycles, it wasn't really proving to us to be a big problem that people weren't completely were gaming the system a bit on those. It didn't matter enough. And so we also had jobs scheduled to multiple sites. And so we have other ways of scheduling jobs because we support all these grid tools, but we decided to try and use Moab. The actual data placement and staging in Moab, when we were trying to use it, was not very reliable, and it just, again, didn't seem enough reason to continue with it at the time. So all these things, we might go back and use them, try them again as our particular requirements change. It just happens at the moment. We've tried all these things in the past, and it happens we're not doing any of them anymore. So over the years, these are some things that we particularly have requested, and so right from the very start, we had, at the time when we first started using it, we had the largest public GPFS deployment in the world on a big, one of the early IBM Blade systems, and we had just huge amounts of trouble with GPFS. So we asked for this health check to be put in, which was used an awful lot and taught for quite some time after that. There's also other things. One of my site leads particularly likes running jobs, the parallel jobs that fit in all over the place. So we had the -procs directly put in. I'm not a huge fan of this because it causes a lot of fragmentation. You have to put in a lot of other rules to fix it, but it does mean jobs start very fast. But we also had other scaling features put into Talk and PBS. And then in Moab, as I said, we've had these various things to do with fair share around accounting groups added to the system. Various things to do with accounting around reservations, usable clock modification, and we've asked for this last one, someone. That's one that's still causing us problems. So it would be nice if that would get off the ticket and make progress. And so we had very, very good discussions about features in the first few years. And so I remember Doug Whiteman from Cluster Resources Stroke Adaptive saying that we found it was very odd the way that every problem we had to be addressed by the company's CTO, and he had to make a site visit to fix every problem. But it turns out that Dave likes the mountains, so you know, live next to a mountain if you want great support from the CTO of the company. That's it. We've been using Moab scheduling for over 10 years now. So we currently have policies local to each site, so we're not doing some of the multi-site things we have in the past, but we're just not finding that they're necessary at the moment. And recent feature requests have really been about new architectures, issues with getting things to work on very big shared memory systems, so over 2,000 cores, and scheduling with GPUs. But much less sort of subtle scheduling issues than we had in the early days. So that's it.
Yeah, so are there any questions for Rob?